All right, let's talk about that AI that feels, well, like straight up magic. We're going to pull back the curtain and really dig into how these incredible new tools actually work, or if work is even the right word. You've probably seen this yourself, right? You type in a simple request and bam, out comes a perfect piece of code, a spot-on summary of a super dense article, or even a poem. It's kind of wild. The output is so good it feels, well, impossible. So how does this digital magician actually pull off its tricks? And that's the million-dollar question, isn't it? Is this thing actually thinking? Is it conscious? Or is it just a really, really sophisticated parrot? To figure that out, we've got to look past the chat window and deep into the architecture. So, that brain behind the chatbot has a specific name, and it is the key to this whole thing. It's called a large language model, or, as you've probably heard, an LLM for short. The best way to think about an LLM is like autocomplete on steroids. Seriously, it has been trained on a mind-boggling amount of text from the internet. We're talking books, articles, websites, code, you name it. And its one single goal: to predict the most likely next word in a sentence. That's it. It's a prediction engine, just on a planetary scale. And this is where things get really crazy. From that one simple job, just predicting the next word, all of these other amazing skills just emerge. It was never explicitly programmed to summarize an article. It just got so good at predicting the words that make up a good summary. It was never taught to write poetry. It just predicts the most poetic next word. It's all just incredibly complex pattern matching. So the large language model, yeah, they are not kidding. We're talking about models with over 1.5 trillion parameters. Now, you can think of a parameter as a tiny little knob, kind of like a connection in the human brain. During training, the AI is just tweaking every single one of those trillion-plus knobs over and over until it gets incredibly good at predicting text. That massive number of knobs is where all the power and nuance comes from. But how did we get here? Well, this technology didn't just pop up overnight. Nope, this was built on decades of research, all leading up to one critical breakthrough that basically unlocked everything we're seeing today. You can see it's been a long road, but the absolute game changer came in 2017. A research paper from Google called "Attention is All You Need" introduced something called the transformer architecture. See, before that, models had a terrible memory. They'd forget the beginning of a sentence by the time they got to the end. The transformer gave them a way to pay attention to the most important words, no matter where they were. That was the key. It unlocked a true understanding of context, and it changed the entire game. Okay, so the transformer is the blueprint. But how do you actually go from a blueprint to a full-blown digital brain? Well, it is an absolutely massive engineering challenge. Let's break it down. It's basically a 4-step recipe. First, you need to gather a library of text that's pretty much the size of the entire internet. Second, you gotta chop all that language up into pieces the machine can actually understand. Third comes the really expensive part, the massive training process. And finally, you have to polish it up and teach it to be helpful and safe. So, about that chopping it up part. A computer doesn't see words like tokenizer the way we do. It sees tokens, like token and izer. The process is called tokenization, and it's kind of like breaking down all of human language into a giant box of Lego bricks. This way, the model can build any word it needs, even new slang or super complex terms, just by snapping these common pieces together. Now for the main event, the pre-training. And this is where the costs just go through the roof. We're talking about taking an army of supercomputers and running them full throttle for months on end. The electricity bill alone can be millions and millions of dollars. This staggering cost is the biggest reason why building a brand new top-of-the-line model is a game that only a few giant companies can afford to play. Okay, after all that training, you've got this incredibly smart text predictor, but it's still pretty raw, kind of wild. The final step, fine-tuning, is like sending the AI to finishing school to teach it some manners. Using a technique with a fancy name, reinforcement learning from human feedback, real people actually sit down and grade the AI's answers. They give it a thumbs up for good responses and a thumbs down for bad ones. This is the secret sauce that turns that raw engine into the helpful conversational assistant you actually talk to. All right, so now we know how they're built. But let's get real for a second. For all their amazing capabilities, these tools have some very real and very persistent flaws. There are two sides to this coin. On the one hand, you get these mind-blowing, emergent abilities, skills that nobody programmed in. They just
appeared as the models got bigger. Things like being able to reason step by step to solve a puzzle. But then there's the flip side. The biggest issue is what we call hallucinations, which is a fancy way of saying they just make stuff up. And they do it with incredible confidence. They also soak up and amplify the biases from their training data. And they can be tricked into breaking their own safety rules. These aren't just little bugs, they're fundamental challenges we're still trying to solve.
All of this leads us to the biggest questions of all. Now that this technology is not just a lab experiment, but a part of our daily lives, what does that actually mean for our society? Just read this quote and let it sink in for a second. We are officially at a point where we often can't tell the difference between something written by a person and something written by a machine. Think about what that means for everything. For a school essay, a news article, or just trusting anything you read online. The very ground beneath our information ecosystem is shifting. And the list of challenges is huge. We're in the middle of massive legal battles over copyright. We're asking tough questions about the environmental cost of all that energy use. And of course, there's the constant struggle to make sure these algorithms are fair. But maybe the most urgent issue is the potential for spreading misinformation on a scale we've never, ever seen before. You know, at the end of the day, these AIs are a mirror. They have learned from our world, from the vast collection of text we've created. They reflect the best of us, the worst of us, and all the weird stuff in between. So they learned from us. The real question is, what will we learn from them? Not just about technology, but about ourselves.